Hi guys, welcome to the shop. I'm Robin. Today we're going to look at a easy design for large diameter ID lapping. I have some D2 rings that I've hard turned and some other mating parts that I've hard turned on the harding. The hard turning is a lot easier on the outside as far as holding tolerances because it's a lot stiffer. Boring bar gives you a lot more deflection, so getting these boards straight within a tenth or even a half thousandth with the hard turning is a little difficult. So the IDs I lap. This diameter here and these, this is what the lap design looks like. I have a lot of different things I need to lap that are large diameters, and I needed a economical way to be able to make a lap of various sizes quickly and easily. This one is cast iron. Just happen to have a chunk of iron. That was what I lapped this large diameter bore here with on this. This one's aluminum. Aluminum works just fine as a lap, actually works real well. And that's what we used on that. So the design of this is pretty straightforward. This is an expander from a normal purchased barrel lap or a blind hole lap, the standard ones you can get from your various suppliers. And the way that I designed this is I have two M5 screw holes in the back that hold it on and provide the torque. And these don't get tightened, they just get snugged so that the lap is still able to expand. So when these come out completely, they're engaged a long way because they get a lot of lateral side loading when they're in use. You don't put a huge amount of torque on these things because typically you're holding the part by hand, resisting the torque of whatever you're driving it with. I have a 3/4 nose on this that I use for driving it with a 3/4 collet in the Bridgeport. And as soon as I get this long screw out of here, I will be able to see what's going on. Okay, so there's the two screws. They like I said, they drive. They provide the driving force. And then there's a pilot that centers it. So when you make the lap, it's actually just a we turn the solid diameter. We put our pilot hole, 3/4 pilot hole. We just put an actual ledge on here for the expander screw to hit on. I don't turn a matching tape or whatever. I just have a little shoulder down in there that allows it to hit on the shoulder. Once I've done that, I drill my holes. I drill and tap my mounting holes. I drill these flex holes, just taking a visual interpretation of what would be a good amount of flex space there. And then I bandsaw through right to the center. Once I'm in the center with a 3/4 blade, I can turn and go through and notch these out. Go out to each one, and that's what lets it expand relatively uniformly. Once I've done that, I'll put it back on the arbor, put the expander in, expand it a little bit, then I'll actually turn the diameter a little undersized. I'll put my grooves in for lubrication and carrying the slurry in there, and turn the accurate OD. So that's how it works. Now we're going to start making the two laps, two different diameter laps. This is a chuck that I have dedicated to soft jaws, and right now we're just going to face off these two chunks that I happen to have on the stock rack. The reason you see me pulling the chips away here is I didn't want to clean out my chip pan of steel because I'm just doing a little bit of aluminum turning, so I'm just grabbing the chips and throwing them in my aluminum bucket instead of letting them fall in the pan. So facing off, turn the OD, rough OD of the lap. Just getting these ready to actually go into the mill to do the holes and the slotting before they get finished. So working on the big one now in the soft jaw chuck. Soft jaw chucks are very handy. Basically, it's you have bolt-on jaws that are machinable, and they run very true if you have a decent chuck. You bore them in place, and so that lets you grab a piece like this, and you'll notice I'll be putting these parts in and out frequently and not having to indicate. So just breaking the edges there with a file. Now we're moving over to the smaller one. and doing the same thing. And through the magic of video, we're already finishing up the very last side here, facing it off. Putting the drill chuck on. One of the beauties of having the fixed tool post, you see the compounds removed, and I have this big solid block I made there that holds the tool post aligned. There's set screws on the back corner there to keep it from being able to pivot, and allows you to put things in like this. Digital allows me to put it right on center. And now we're whacking the holes in there for the expander. Little makeshift coolant spray guard there. Just like the grinder, I just use coolant all the time on the lathe. Just doing too much work that requires the benefits of coolant, turning a lot of tool steel, and just one of those things that if you're actually producing a lot of stuff, you just got to use it. Here I'm doing the bore and the step for the expander to sit on. The expander just sits on the sharp edge of that lower lip that I'm putting in those. And you can see the beauty of the soft jaw chuck there, just being able to throw things in and out, in and out, in and out, and use various tooling on it. Just really saves a lot of time. That's only like $175 chuck from Shars, and then after a day's worth of cleaning, de-burring, fitting, it's actually a pretty nice chuck. So throwing some chamfers on there, and just doing both sides. Chamfer on the other sides. Now we're putting the large outside bevel on. That's to allow the lap to get started in the holes easily without needing to be aligned too perfectly. And it's extra big because there's still some material on the outside to be removed after we do the circular slots and the axial slots in this. Now we're over on the Bridgeport and getting ready to indicate in the center. Get ready to use the digital for the bolt pattern on there. I'll be using the digital readout bolt circle function to put in the 6-hole bolt pattern. But first I'm doing the 2 M5 tapped holes that are for the screws that actually supply the driving torque. So just spot drill, and I'm be power tapping here. I have a DC motor drive on my Bridgeport, and I can just hit the reverse button there at the end and just back right up out of there. Pretty handy. Over here, when I go to the side here, all I'm doing is taking a scale interpretation of where I want my bolt pattern to be. So I'm looking at my wall that I want, and then saying, okay, that's my bolt radius, and then moving over and doing my bolt pattern with the large drill there, and just some water soluble oil coolant there. Just blasting the flex holes in there. Notice I'm paying attention to my parallels, moving them out of the way so I don't drill into them. I've never really drilled into a parallel. I just saw it happen one time. Haha. See, just whacking the holes in there. And now we're moving to the small one. Won't bore you with all the details. There's the last hole in the small one. And those two are done for the holes. De-burring the edge of the holes before we go over to the saw.
sawing through from the outside. Once I get to the center hole, sorry for the poor camera angle there, I wasn't paying attention, you can't really see where I'm sawing, but basically you can see I'm just spinning it around in the hole and then coming right back out the same slot. Air tool, doing the just deburring all the edges, just running right down through the slots, laying it right in the groove there, and going around getting them all deburred. The slots there in the drive arbor, you see they're slotted so that the arbor can expand and not have the bolt holes bind. Putting some lube there on that shoulder, that lip where the taper expander actually hits. Like I said, that's a standard expander from a purchased blind hole lap. Popping the soft jaw chuck off, putting a 1-inch collet in to grab the larger diameter of my lap arbor, and got a little expansion pressure on there so that the expander is actually loading the lap a little bit, just enough that it's in contact. Now we'll do a diameter just a few thousandths larger than where I'm going to end up, so we know where we are, taking a finish cut across. Now we'll do our grooves, and now this I'm just using the dials on the hand wheels and doing like a 0.1 spacing, going in there with a V groove tool, just putting circular coolant or grooves to hold the lap slurry. You can see I'm just plunging in there and moving 100 thousandths plunging. Now I'm going to put a tool in sideways, and I'm going to use the lathe as a actual slotting a shaper. There's the tool there. Just a little V groove tool there, a positive rake, but that's putting in there sideways, and actually going to use this as a shaper and put the grooves in axially. Just tightening the tool in there. Remember where the tool's cutting sideways. I'm going to be moving the carriage back and forth. And put some TapMagic Aluminum on there just as a lube, since I'm literally going to be plunging through there one cut, full depth, probably about a good 20-30 thousandths deep. And I'm just plowing through in one cut. You see me touching the diameter there. Now I'm going to crank in my full depth there, probably 20-30 thousandths. And now one cut, back up, and I'm just holding the hand wheel in the back of the machine, moving, holding it still while I go in and come back through the same cut, and just march my way around. Now I'm getting serious about it. Just whacking my way around there, just visual. It's just for the slurry to have a place to get in between all the spots and lubricate. And we're done with that. Now we'll do a finish cut at about maybe a thousandth or two under the actual size that we're lapping. Leave some room for the actual particles as they embed in the aluminum, or whatever the lap's made out of. And the lap is expanded a little bit. There you can see what it looks like. There's the grooves, and that really helps with the lubrication. And that's what the whole thing looks like. Now we've got our rings. These are rings for a particular type of molding. They needed a real, they wanted a really decent finish on there. They didn't want any tool marks or any feed lines or anything. They wanted a really smooth finish on these. So the reason I'm working at the bottom of this at the moment is because there's a little bit of taper, probably maybe 3 or 4/10 taper in these from me hard turning these. This is like 60 Rockwell D2, so not trivial stuff. And D2 is 12% chrome, and chrome is pretty abrasion resistant, so not crazy hard to lap, but it's tougher than your average steel. And same thing here with all lapping. I'm holding this by my hands so I can feel the torque, where the torque is greater, and I'm focusing on where there's more material being removed. And because of the taper, most of it's down the bottom there. and take it out. You can see where the finish is shinier at the bottom and it's not so shiny at the top because it's not actually cutting at the top yet. Take my Allen wrench, tweak a little more feed on or a little more expansion on there, and you want just enough that you're cutting. If you push too hard, you'll rip the particles out of the aluminum. They'll just tumble around and not cut. There's a happy medium there where you've got enough drag to cut well, and plus being able to hold on to it. And I do let the part slide in my hands. Anytime you're lapping, you always want your position of the parts to constantly change, because your hand influences the shape, the machine setup influences the shape. So by letting the part constantly change position, by letting it slowly rotate, you let those things average. Cleaning out the part here, take a look at what's going on. You'll see that we've got a shiny band, then it starts to be matte towards the bottom. Shiny is where the lap's actually cutting. The matte part is where we've just got tumbling abrasion going on in the larger diameter where it's not, the lap hasn't cut out that far yet. Now we're going to change over to the larger lap, removing the expanders plug, taking out the screws that hold the lap on and provide the torque, popping it off, stick the other one on, put the drive screws back in. The screws just get snugged. This lap still has to be able to skid. Got the expander, got some blue Moly on there, especially important where you've got the bearing on the aluminum, that it doesn't gall. Here I'm using my scale to make sure that the lap's going to clear the vice jaws, opening them up. Checking my setup here out. And you remember I mentioned about protection. Well, I finally wised up and said, hey, let's put some protection on the vise. I was a lot more careful making sure the slurry didn't get into the vise before, but now with what I'm putting on now, I'll be able to be a lot sloppier. Burnishing the tape down, transfer tape down, and peeling up the backing, and just using a piece of plain 8.5 by 11 paper. Now we've got helps prevent the slurry from chewing the top of the vise jaws, and now we're getting ready to charge the brand new lap, shaking the slurry. Slurry keeps settling constantly, so you're always shaking it to keep the diamond in suspension. This is 15 micron diamond that I'm using on here, and didn't have enough torque on there yet. If you don't have enough expansion, you'll just have tumbling action going on, which is good for rounding the lap up, but it's no good for actually removing material. You got to get to the point where you force the diamond particles to embed in the softer lap and cut the harder part. It's actually easier to lap parts that are very hard than it is to lap ones where the material is close to the same hardness as the lap. Putting a paper towel down here on the bottom just to catch the extra slurry, and I've also used some just spray lube here sometimes just to get rid of the metal particles. Now you can see that shiny band starting to widen up as we're taking the undersized section out of here. Checking the inside diameter with inside mics. The actual absolute size of these things isn't important, but the match to its mating part is. So by using the same mics, outside mics on the inside mics, it's easy to hold a very close tolerance of the fit of these. We only have about a half thousandths clearance on this diameter is what they're shooting for. Add a little more expansion to the lap, Going back in, adding some slurry, and just going down through. Like I said, probably had several hours of lapping on these parts before they were done. Now we're just cleaning up the, taking the lap out. You'll see that matte finish on the outside of the lap. That's where the particles are actually charged into the aluminum. Charged meaning they're embedded into the aluminum. Peeling off the protective paper there. Cleaning up with some alcohol. Getting rid of any, using some alcohol to blow out any residue that could be in there. Razor blade to scrape off the transfer tape. Getting rid of all the residue from the tape. This is pretty rare. That's an actual crack in the D2, a flaw in the material. And what you're seeing is the magnetic action that's going on around that crack is actually causing the D2 particles that have been abraded off to lay across the joint. Here it is cleaned, and you can see that crack in the polished parts. Here's the final bores. You can see the reflection of the inside mic in the bore there. And like I said, these are mold pieces used for a particular type of molding operation. And the pieces in the back, the larger pieces, were lapped with the same large lap, just larger versions of it on the same holder. I'll be doing some more, another video on actual lapping in general. A lot of details involved with it, but I hope you found this interesting.